Hi, myself Anita Anthony. I hope all you are interested to know about DNA computing. Today I present 7-minute presentation. Here I recommended you to a PowerPoint presentation. Okay, let's start. In this slide we includes introduction for DNA computing, need for DNA computing, limitations of current problems that faced in DNA computing and its applications, advantages and disadvantages of DNA computing, and also discussed about why don't we see DNA computers everywhere, as well as the future of DNA computers. Apart from this, at the last we go through some queries. Let's go to introduction part. While seeing this, the first question go through our mind is, what is DNA computing? The word DNA stands for Dynamic Network Analysis. It's an emergent scientific field that brings together traditional social network analysis, link analysis, social simulation, and multi-agent systems within network science and network theory. The first idea was proposed by Professor Feynman around 1950, and the first important experiment was held in 1994 by Leonard Edelman. Here, each DNA strand represents as a processor in our computer. Let's discuss about the history of DNA. This field was initially developed by Leonard Edelman of the University of Southern California in 1994. Edelman demonstrated a proof of concept use of DNA as a form of computation which solved the 7-point Hamiltonian part problem. Since the initial Edelman experiment, advances have been made and various Turing machines have been proven to be constructible. Then we move to the origin of DNA computing. DNA computing is utilizing the property of DNA for massively parallel computation. With an appropriate setup, the enough DNA, one can potentially solve huge problems by parallel search. Utilizing DNA for this type of computation can be much faster utilizing a conventional computer that we used in nowadays. Then, why is DNA computing important, or what is the need for this? It has a clear advantages over conventional computers when applied to the problem that can be divided into separated non-sequential tasks. The reason is that DNA strands can hold so much data in memory and conduct multiple operations at once, thus solving decomposable problems much faster. That is, its storage capacity is much higher than the silicon chips. Here, 1 cubic nanometer of DNA is sufficient to store 1 bit information. But nowadays, DNA computing is not implemented to our PC due to its limitations of the current problems that we face today, such as it involves a relatively large amount of error, it requires human assistance, and also it's a time-consuming laboratory procedures, and it have no universal method of data representation. Here are some applications of DNA computing. The first one is DNA chip that are familiar to us, and the second one genetic programming. The next is pharmaceutical applications, and next is cracking of coded message, and the last one is the most familiar to us, that is DNA fingerprinting. By watching movies we hear about that DNA fingerprinting is used to find the crime. Let's know what is DNA fingerprinting. DNA fingerprinting is a laboratory technique used to establish a link between biological evidence and a suspect in criminal investigation. A DNA sample taken from a crime scene is compared with a DNA sample from a suspect. If the two DNA profiles are matched, then the evidence came from the suspect. By using this method, we can find the criminal. Here is the image that shows the implementation of DNA computing, that is programmable chemical oscillator made from DNA. And also DNA computer can sense multiple antibody inputs with potential for smart drug delivery. Here is the pictorial representation of DNA computing. So let's know about the advantages of DNA computing. It performs millions of operations simultaneously and generate a complete set of potential solutions, conduct large parallel searches, and its efficiency handling massive amount of working memory. And it is cheap, clean, readily available materials, and also it has amazing ability to store information. And also it faces some disadvantages, such as even for some relatively simple problems may require impartially large amount of memory, that is loads and loads of DNA strands are required. And also they are not programmable and cannot sit down at a familiar keyboard and get to work. That is why we don't see DNA computers everywhere. Due to this, DNA computers could not replace with traditional computers. And also the average dense cannot sit down at a familiar keyboard and get to work with this. We hope that its future becoming more colorful than the present condition. DNA manipulation technology has rapidly improved in recent years, and future advances may make DNA computers more efficient. Hope that the replacing of transition computers by high-end research-oriented computers in future. Here be the queries. Here be the queries for getting a clear idea of this. Let me conclude my presentation after seeing a small code. Put a little smile, it's make different from others, so always keep smile in your face. That is the big gift to hand over to others. Thank you.